What's up, guys? Mr. Answer 414. I'm going to go over this Module 3 review, which is all about quadratics, completing the square, finding solutions via a graph, complex numbers. Also, it's NFC Championship weekend. Go Pack Go. We're out here with the nameless jersey representing. So stay tuned. If you have questions at the end, let me know. Comment down below. Make sure you guys are getting ready for finals. All right, so quadratic equations refers to anything with x squared. The graphs make parabolas, so you just want to know the perfect squares here. Square the number. I would try to memorize as many of these as possible. To solve by factoring, you need to solve so that you are equal to 0, and then find the factors that multiply to the x side. So if you look at the x squared minus 16, it's a x minus 4, x plus 4 situation. You set those equations, those factors equal to 0, and solve them to find the roots. Those are the solutions. Taking the square root, a number that multiplies by itself, make sure you get the plus minus in. Those are your double root situations. Just make sure that you know what the square roots are. In this situation, I should have rationalized this one. I didn't. But if you have a square root in the denominator, make sure you rationalize. If you can't simplify, that's fine. So here, just looking for the roots. The x-intercepts are your roots. So you can do that by graphing, factoring, taking square roots. There's more than one way to find a solution. So in this situation, you need to write the equation, and we're solving for t because t is time. You'll notice that it's plus or minus a second. Half second, I should have just put plus 1/2 because time cannot be negative. Again, I know this is going a little fast. I'm doing this voiceover stuff, so pause it and go back if you need to. So for this one, we know that 0 would be how high the ground is. We plug that in. On this one, we're solving for t. You can also put that in the calculator to get a decimal for a more precise answer. Geometry problem, just areas, length times width. You're given the side lengths, they're squares, so it's obviously going to be x squared and 2x squared. Make sure that you can do that math and get the value for x. So you'll see here, I got the area for the first one, I got the area for the second one. The area changes dramatically. For this next one, you just got to set it up. The second area is reduced. Plug in what you know and then solve. In this situation, you have to get all the x's on one side so you can solve the quadratic equation. In this case, I am going to pull out the 7. And then I'm going to find the factors and set them equal to 0 to find the roots. This should have been plus or minus. On this one, I always try to draw a picture so I can make sense of things. If I can't see it, I'm probably going to make a mistake. So just use logic on that one. We just made a graph, and we know that they're symmetric because it's a quadratic. In this case, you have the negative square root, and that's where we bring in the complex number, the imaginary number I. If you have a square root that's negative, you pull it out as a I, and that's why the square root of negative 36 is plus or minus 6i. So here you go. You see all the answers to the ones before. Simplify as much as you can, and then write it as the imaginary number I, or complex number depending on what you're given. So you're looking for the to get rid of the negative square root. So we graph this. The x-intercepts don't exist. So they do, though, but not in the plane that we're used to. They are imaginary. I know it's an abstract concept, but they do exist. The real part is just your real numbers, the numbers that you've been knowing. Imaginary, so anything with the I in it, when you put them both together, you get complex numbers because it has both parts. And that's written as a plus bi, which you can see that format, especially in letter A. Adding or subtracting, it's just combining like terms, just like you would with x's. Powers of I, when you have different powers of I, they reduce to different things. I would memorize this chart, and then to do this, you just divide out by 4, find how many whole groups you have, and then the leftovers are going to tell you what you got. So those are the answers. I just divided and then checked with my chart to figure out what I was given. Make sure that you know those charts. I know the powers of I by heart. Multiplying, treat it just like multiplying x's. But you got to remember that if you get I squared, I times I, that it does reduce to -1, and that will change your simplified answer. So please take the time to do that. Again, I know I'm going kind of fast, but pause it, rewind it, ask questions down below if you have them. You'll see those are mostly complex numbers. Squaring, you're just multiplying that term. Make sure that when you do that, you remember what I is. This is just getting the perfect square binomials. So you're finding the C value that completes the trinomial, so you can factor it out. X minus 5 times x minus 5 would definitely equal x squared minus 10x plus 25. So check your work. Now completing the square, it's not complicated if you know the steps. The whole idea is to find the missing piece to make that perfect square. And if you don't make the perfect square, it's not going to work. Make sure that a is 1 when we do this. You'll see the setup for step 1. I'm giving myself a placeholder to add in that constant. You take the b value, divide it by 2, and then square it. Add that to both sides. That is that c in parentheses or quotations. After you do that on the left-hand side, you should be able to get that binomial squared. Take the square root to solve for x, do your math, get your answer. You may or may not have an imaginary number, a complex number, a real number, it depends. Look over. I tried to show my work clearly with the steps. Just reference those 6 steps. If you have questions about that, let me know. Again, make sure that a is equal to 1. If it's not going to work. You'll see that my number's there. I personally like dealing with fractions on these because I can reduce them better. Decimals work too. They just get messy, so do what works for you. Now, the discriminant is the value under the square root in the quadratic formula. Quadratic formula is a way to find solutions that always works. You definitely want to know this by heart, what a 2 solution, 1 solution, and 2 imaginary solutions situation looks like. And you're not using the quadratic formula here. You're just going to test the discriminant so you know what you're getting. So whatever that value is, compare it to 0. If it's greater than 0, equal to 0, or less than 0, you have your different situations. That is a skill that's going to help you a lot in terms of checking your work. Quadratic formula, though, you can always use it. So you may forget how to use completing the square, but you won't forget quadratic formula. And you can sing it to Pop Goes the Weasel. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. That's how I know it. And you may not want to sing it because you think that's lame, but you're lame if you don't know math. So back here, we're going to use quadratic formula. We're going to solve to get our ABC, plug it in, get your solutions. And that's really all I got, guys. Good luck. Study up. If you have questions, let me know.